Welcome back for this sixth module. Now we're going to see how to load some of our assets, create some beautiful universal application, and then how to unload also offline. So we are still the two Davids. So I'm David Rousset, he's David Catu, and we're both working for Microsoft, loving 3D and HTML5. So this is the second module of this second day, so we're going to learn how to load some assets and handle them, enable offline, and creating also some application for the Windows Store if you want to. And before starting, let me show you what you could do when you're loading some beautiful assets and your gaming studio, for instance. So what we've been working with is with Ubisoft, so you can see on my screen, so based on the Assassin's Creed Pirates license, so they've been using an engine, and together we've built this demonstration to load the assets. So this is the ship from Assassin's Creed. You can go on board and see how it's beautiful. You can see all the water using some pretty cool pixel shader effects. Now you know what pixel shader is. You can even change the weather if you want to. So this is a very beautiful scene. And to do that, what they've done, they simply work with the 3D designers to enable this scene and load the assets. And you can even see that you can control the ship. This is a very simple race game you can build using BabylonJS, and this is obviously built by some very cool guy from Ubisoft, so you got some stunning graphics. So if you're interested in doing that, you need now to listen to David.
Not for the design part, just for the technical part, yeah. So, Ubisoft use 3ds Max Explorer to generate everything, and they add to load the assets into this specific application for the web. Okay, so going back to our agenda, we will talk first about how to load a scene, how to load meshes, and we will also talk about a new feature we introduced in the very latest version of BabylonJS, the Assets Manager. Then, David, you will present us how we can use everything that we talk about and create an application for Windows and Windows Phone.
Yes.
And finally, you will explain us how to use HTML5 offline mode to support offline scenarios. Okay, so before doing that, let me move to the section 1 and let me explain you how we can simply, because we love the simplicity, how we can simply load things. The very first thing we can load is the scene itself. We saw with Blender and with 3ds Max that we can easily export a .babylon file, and inside this Babylon file there is everything. The camera, the meshes, the lights, texture are alongside the .babylon file. So how can we do to load everything? There is a very simple way to do that, and let me demonstrate you how we can do that. So let's start with this very simple page. We start to know it. It's a simple HTML5 page with just a reference to BabylonJS itself. No margin, just a full screen canvas, okay? And I already get the canvas, the engine is already ready to work, and I just have my resize event. So if I resize my screen, everything will follow. Then what I want to do is load my V8 engine, which is a V6 engine. This is not the very simple part. What I want to do then is go through this specific folder here, as you can see, and I want to load the v8.babylon that I just created before with 3ds Max. Okay? To do that, I have to use a really powerful tool, which is the scene loader object. It's a static object where you can find two specific functions. The very first one is load. The second one is happen. If you want to load a new scene, then you will use load. And if you want to happen a scene into another one, then you will use happen. That's pretty simple. With load, you have to precise where is the data. So it's on the V8 folder, okay? What's the name of the Babylon itself? So it's v8.babylon, all right? And then which engine do you want to use? We didn't talk about that, but we may have one engine per canvas. And if you have two canvases in your scene, in your HTML5, then you can have two engines. That's not a problem. And we have to provide a callback function that will be called for you once everything is loaded. Okay? This callback will give you a scene here. That's pretty simple. So once the v8.babylon file will be loaded, the scene will be created for you, and the function, the callback function, will be called with this specific parameter. What I have to do here is just say, hey, okay, this scene will have a camera, and this camera needs to attach control, remember that, on the canvas. This is an important point if I want to control everything. And once I did that, the only remaining thing is the render loop itself. So once the scene is loaded, let's run the render loop itself. The anonymous function that I will use is extremely simple. I just ask, as before, scene.render, and that's pretty much it. Extremely simple. And you will see that the result is even simpler than we can expect. Let's have a look. I don't know if we can see that. Yeah, just I'll start again just to see the loading screen. Did you see the loading?
Yep.
Yeah, it's free. Just by calling sceneloader.load, we will instantiate for you a sort of layer on top of your canvas just to let the user know that we are loading something.
Okay.
Not just a blank screen where all the user will, what's going on in here. Just by calling load, everything will be loaded for you. You will have access to a fully prepared scene where with everything is accessible, like for instance here the active camera, but I can also get any kind of object, play with what I want, and obviously when I render loop my scene, everything is working. It's like less than 10 lines of code to just load what I want.
So for the developer part, it's really simple to use.
Yes, if the designer is good enough, you just have to load and then play with the object itself. All right? Going back to the slide. So the important thing that we have to notice here is that the assets are loaded asynchronously, meaning the scene can be loaded, but perhaps texture won't be ready because we have to load them asynchronously. So the scene is okay to render, but in the very first time, a lot of things may be missing. That's why we added the loading screen. The loading screen is here to be sure that everything will be loaded for you. Let's have a look at this demo again. And I want to open F12. Let's move that in here, this one here, okay. And let's have a look to the network itself. As you can see, the page is loaded, Babylon.js is loaded. We try to load the manifest, but I know that we will speak about that after. We try to load the V8 object, that's perfectly fine, and then all the textures required by this scene are loaded for you. When everything is loaded, then the loading screen is hidden for you, and the scene is displayed.
Okay.
You just have to do nothing. This is what we love. Then, you also have the option to control by yourself, if you want, the loading screen. For instance, you want to load something in your own side, on your own side, then you just have to call show loading screen to show the loading screen on top of the canvas. Then you can call hide loading screen if you want to hide it. Let's have also a demonstration of that when you want to deal with a mesh. This time, I have a scene. This scene is already existing, and I just want to import a mesh from a specific .babylon file without having to import everything. I'm just interested in just one specific object. Let's say I have the ship from Assassin's Creed. I just want the ship itself. I don't want the sea and rocks and island. I just want the ship itself, and I can just grab this ship from the .babylon file itself.
Okay.
Let's have a look. And here. So instead of loading everything, what I can do, sorry, not the right file. What I can do is just create a scene. So I create my scene on my engine. I define a light, okay? We know that right now. I define an arc rotate camera. I attach my arc rotate. And I just specify something interesting here. Before every rendering, I just want to move the light where the camera is. So it's like if you have a light here. So everything that you are looking at will be correctly lighted, because the light, you are the light. David, you're light.
Yes, thank you.
So what I want is to open this .babylon where there is a skull. I just want to grab the skull from this scene and not the camera, light, everything. But because my scene is ready, I just want to import that. To do so, I just have to do a really simple thing. But before doing that, I want to give a feedback to the user that I will load something. So instead of hacking around, I can just say, hey, please display loading UI. That's it. Let's just watch that. Okay, I have my loading UI. Once
now you need to do something.
I need to do something, yeah, because BabylonJS is powerful enough to do a lot of things for you, but you have to code at the moment. What I want to do is just ask, once again, the scene loader, but instead of using load or happen, I want to use import mesh. Okay? So import mesh is here, and import mesh will take, for instance, here, the name of what I want to import. Okay? So I know that the name of my object is test. Sorry about that. I don't know who created that, but they call the mesh test. The mesh and the file itself is in the skull, as we can see here, is in the skull folder, not skill, but skull. Then the file I want to load is skull.babylon, all right? And same story, I need the scene where I want to import in my object, and obviously I will have a function with some parameters, but I don't want parameters. This function can give me all the meshes that I imported. This is a callback function, all right? So I just have to say, hey, I need something. I need my new meshes. Sorry about that. So all the meshes that I loaded from this specific file will be put into this array. I try to give you everything on screen. Then what I want to do is say, okay, let's set the target of my camera to, for instance, one of this object, the very first one. So the camera will look at this specific one, all right? And then I just want to say, okay, I can now hide the loading screen because everything is loaded.
Everything is ready. Okay.
Yep. Okay, the loading was extremely fast, so we didn't have time to see the loading screen, and obviously because everything is local, but on the web it will be big.
Yeah, you will see the screen because it takes much time.
I can add some timeout if we wish, but that's fine. All right, let's do that just quickly because we have time. So let's add some timeout because I really love our loading screen. Let's wait for 3 seconds. Okay, so once everything is loaded, I wait for 3 seconds just
to simulate the network load.
And I'm okay. Just wait, 1, 2, and okay. And as you can see right now, my scene is already set up. I just imported the test object, which is this wonderful skull. This is my skull. This is me.
Impressive.
Impressive, yeah.
You've been using Kinect to
no,
build it?
I don't know where I found this one. And as you can see, everything used the light correctly. And as you can see the specular here is exactly at the opposite of my camera. And even if I move the camera, the specular is always in the center because the light
is following the camera.
This is a really interesting thing if you want to display some 3D object and if you don't want to have issues with the light.
Okay.
Okay, that's perfectly working well. And let's go back to the slides. Finally, I want to talk more about a new feature we introduced. A lot of users ask us to make even simpler how to load things. For instance, you are a web developer and you want to create a game. You have to load a lot of meshes. One for the ship, one for the enemies, etc. You also have to load text files, for instance, containing the translation and things like that. You have to load the music. A lot of things have to be loaded before you can really launch the game, right? So what we did, we created for you an assets manager. This asset manager is a central tool that allows you to organize loading of everything. And once everything is loaded, then because it's an event-based object, you will be notified by the assets manager itself that everything is okay, or we encounter some issues and you have to deal with that. So let's have a look at this demonstration. Same story, I have my canvas, my resize event here, I create a scene, a light, and a camera. Nothing really new here. What I create right now is an assets manager, and this assets manager is attached to the scene itself, okay? And then I can add tasks. For instance, I can say, hey, please, we have to give a name, load a mesh. So I didn't give a name, so load all the mesh. But if I just want to load the test mesh, it is how it can work. The file is in the skull folder, the file name is skull.babylon. Then we have the way to handle success and error on a per task basis if you want. So the task here have on success function that allow me, for instance, to move the loaded mesh to a specific position. Once it's loaded, I can do something. The asset manager also have on task error and an on task success if you want to handle error, not on a per task basis, but mostly on a global way, all right? And on every error, I just say, okay, we have an issue, here is the issue, we have an issue with this specific task. We can have different way to handle that, it's up to you. Then I also have another kind of task. This one is add text file task, always a name, and the file you want to load. And once the file is loaded, for instance, I have an on success, and the task.text will be filled with for you. I can add just a breakpoint here. Same story if you want to load some JPEG or music file or whatever, which can be binary, you do exactly the same thing. We have a global event called onFinish. So when everything is okay, when I downloaded everything, then I can render, so I can run my render loop, right? We can also control the back color. You see that the loading screen is black with white things on top of it. We can control the back color. And there is an option to also remove the by default loading UI if you want to deal with your own loading UI, obviously. So first of all, let's start without debug. As you can see, everything seems to have worked. Let's start right now with debug. And I can see that the task Babylon.AssetManager works. It sounds like, yeah, this is the right text. So he called me here, and once everything is okay, and he called me here. So I just have to launch my render loop. Obviously, everything is loading really quickly right now, but on a really slow network, you will see the loading screen and appearing and fade out when everything is okay. So we have the scene loader. We can control or import scene. We can append or create new scene. We can also control the loading UI. You can change the text of the loading UI itself, as well as the background color. So you have everything here to
build a game.
To build a game, yeah, because all the assets will be ready for you. You just have to control them.
Yes, and most of the time, the people, the way they're using it, they're building a big scene, for instance, and we will see that in the next chapter with the physics. So you're loading a big scene built by a good 3D artist, and then you could load enemies inside that and the main heroes by doing some import mesh. So the first step is load scene. Then when the scene is ready, import some mesh, put them in the right position, try to move them, and then launch the render loop.
Absolutely.
So this is the way you're going to use it. Otherwise, if you're not using that, you will be stick to the basic meshes, geometries. You can still build game with that, but it will be a little bit less beautiful than using 3D meshes.
Or it can be a minimal design. I love minimal design, just using box and sphere. Yeah. That's pretty cool. Just last word before I give the mic to David. Don't forget that everything is stored on a web server. That means that the web server only serves MIME type it knows. For instance, it knows that a .jpeg is a regular MIME type, but it doesn't know anything about .babylon, .babylon mesh data, .fx, which are the three file formats that we are using with Babylon. So if you are using IIS, here is what you have to put on your web config. For instance, if you are using Apache.htxs, here are the order you have to add to the specific files. This will let know the server that this kind of file are okay to be served to the client.
And we had a lot of issues on our forums. People don't understand that because maybe they're not classic web developers. They just want to use the browser to host their scene. So what you need to understand is really that this file, .babylon file, is specific files, and you need to configure the web server. Otherwise, you will launch the code, and you will probably have an error, a 404 error, because the web server will refuse to serve this file to the client. So if you've got a 404, it's probably because you forgot to configure the web server to serve the .babylon file.
Absolutely. So right now, let's move to creating not a website, but a web application.
Yes, and we're going to see together that it's pretty simple to build a Windows Universal app or Windows app or Windows Phone app once your code is running fine inside IE11. So this is something very important. So we're going to see how to move from web to apps in 5 minutes, approximately, I guess. And the first version will need maybe 1 minute to build it. So why you don't need a lot of times is because once you've tested this inside IE, you've got the guarantee that this is the same rendering and JavaScript engine being used by the Windows Store app. So this is something very important to keep in mind. If you want to build an application for the store using WebGL rather than Windows Store or Windows Phone, this is possible since starting Windows 8.1 and Windows Phone 8.1. So this is perfectly supported, but you need to test your code on IE11. That will be the rendering engine used by the Windows apps, of course. So I've got this very simple sample. So it's taking what we've just seen with David. So it's going to load a scene built by Michel ago. So again, art.babylon. When it will be ready, it will attach the control to the camera and send and start the running loop. So let's have a look to this specific scene. So we've got the loading screens, and then we can move inside the scene. So this is working perfectly fine in IE11, which is the current version. So let me show you how to build a Windows Store app and a universal application. For that, you need Visual Studio for Windows. So if you've got the Pro or Ultimate version, you probably have everything already set up. But if you want to build an application for the Windows Store, you need to have this free version, so which is Visual Studio Express 2013 for Windows. So this is a free version you can download. And once you've done that, you need to create a new project. And you will see that there is a JavaScript part over there. So you can build application using JavaScript and HTML5. Then you ask to build for store application. And you've got the choice. You want to build only application for the Windows Store, only for the Windows Phone Store, or both. So what we're going to do is to build an application for both stores. So I'm going to enable universal apps. I'm going to create a blank apps, and let's call that MVA awesome app. It's going to create everything for me. So the solution is over there. So what you can see in a universal application is that we've got something that's going to be shared by both projects, the specifics of Windows Phone and the specifics of Windows Store, because there is still some slight difference on WinRT, on Windows 8.1 and Windows Phone 8.1. Everything is not yet perfectly identical on both platforms, so you need to maybe switch a little bit the code between both platforms. In our case, everything is working perfectly in the same way on both platforms, so what I'm going to do is going to put all my code in the shared part. So let me show you how to do that. So the first thing I'm going to do is to remove the default and CSS files. I don't need them of the Windows part. Same for the Windows Phone, default and CSS part. Okay. And now I'm going to put everything over there. So let's go back to my web application. So what I'm going to do is going to open the folder where the files are stored. I need the asset of my scene, so I need the script and the index.html file. This is everything that is really needed in this web application. I'm going to drag and drop that in the shared part of the universal application. Rename the index to default.html, which is the default file being used by the Windows Store apps. And doing so, normally, if I'm pressing F5, I'm now embedded in a Windows application. It's going to load the scene. And now I've got a full screen experience, and it's already working fine thanks to our FPS camera. So this is a Windows Store version, but I cannot move on a Windows phone using mouse and keyboard. So I need to differentiate both versions by doing a simple test. So let's have a look to that. So if I want to go inside the script part, in the main part, I'm going to have a little bit more spaces. It should be better like that. What I need to check if I am currently being run on Windows Phone or Windows Store. And the cool thing is when you're using Windows Store app, you have what we call WinJS, which is our JavaScript library. And WinJS got a Windows Phone version and a Windows Store version. And the way to check that, you can do what we call some feature detection. So let's do that. For instance, when my scene is ready, what I could do is check if I'm currently on Windows Phone. So I could do that way, because this namespace is only defined when I'm currently being executed on the Windows Phone. So if I'm running this code currently on, I'm going to stop the current debug. If I'm running that on my Windows Store app or Windows, it will be undefined, which means that I'm currently on Windows Store. If this test returns true, this means that I'm currently on Windows Phone. This is a way I found to differentiate both platforms. So when I'm currently on Windows Phone, what I could do is to create another type of camera. So let's call it virtual joystick camera. So we already see how to do that. So Babylon.virtual joystick cameras. Let's call it that way. You need a position, so the position will be the position of the default camera, so I need to have access to it. I'm going to replace the default camera and add it to the scene. What I need also is to take the very same rotation, so new scene dot active camera dot rotation. And what I could do also, well, that's it. Maybe I can enable the collision also, but I'm not forced to. Once I've done that, I shouldn't forget to set up this new active camera. So equal to this one. Now, if I'm running that still on Windows, you see that it's going to be undefined. So I'm still running the very first code. So it works fine. Now the idea is to run that on the Windows Phone. So to do that, I need to stop executing that, and I need to switch the startup project to Windows Phone. And I can start that in the emulator, or I can start that on my real device. So I'm going to do that. I'm going to unlock my phone. So this is my Windows Phone, and what I need to do is to use the Project My Screen app. It's going to ask me to take the control. Yes. And you can see this is my phone. And now what I'm going to do, I'm going to modify slightly the project. So let's go back to Visual Studio. I'm changing the manifest file of the Windows Store version. And I want the game or my 3D scene only to be displayed in landscape mode. So I'm ticking that. And now I want to launch the scene on the device. So I'm pressing F5. And hopefully, if it's working fine, it's going to deploy it on my phone. It's going to load it. It should load it. It's taking a bit of time. And as soon as it will be loaded, I should go in the second part of my code on if Windows.phone and activate the virtual joystick camera. Yes. So I can still debug my code.
No, it's new scene.
It's new scene, yes. So it's my fault.
Yes.
So you can see that this was intentional.
Obviously.
Just to let you see that you can still debug the application in the same way you're used to. So let's do it again. So it's going to redeploy the application, take the loading screens, load all the textures, and .babylon file. So this is not a scene that is being built specifically for the Windows Phone, so the performance could be slightly optimized, but still it should run as is. And ta-da! Okay, so it's working fine. And if I'm pressing my thumb over there, you can see I can move the camera, and you can see that I can move with the other thumb. So this very same base of code, so you don't have to change anything. And I've put everything in the shared version, so you don't have to build two versions of the application. You've got only one version of the application for both stores. And using this approach, we have published in the Windows Store. So if you go in the Windows Store here, you can search, for instance, in the search box for Babylon. I guess that you will find it. No. So search for SPLit, and I'm sure you will find it. Babylon SPLit demos. And we've published that to the store, so you just have to provide screenshots and probably to have some specific assets so I can install it on my machine, which is not yet configured for that, I'm sorry. But once you've got your machine configured with a Microsoft account, you will have the application available, and you could build a game this way, publish on the Windows Store, on the Windows Phone Store, and this is not a problem. You can go through the policy checks. It's perfectly supported. So it's really great to see that. I think we are the first platform to support WebGL to build some apps on the app stores. So this is really, really good. So let's go back to the slides and conclude by analyzing how offline is working. So let me tell you my story. So I'm living in France, in the south of Paris, in a beautiful area where the internet access is awful. So I've got something like 2 megabytes per day, yeah. So when I was working on writing the BabylonJS code with David, every time I was trying to load the scene from our web server, it was taking a huge amount of time, but the asset wasn't changing at all. Once the asset has been built by Michel, we can load it, and this is only the engine itself we were modifying. So I tried to think about a way to store all the asset, texture, and everything linked to the 3D worlds in a DB. So for that, I've been using IndexedDB. So to use IndexedDB, it's very simple. So this is really, again, the way we're seeking. You just have to create a .manifest file for your scene. It should be the name of your scene, .babylon.manifest. Then you got to precise the version of the assets you'd like to set up. So for instance, if I'm changing the version from version 1 to version 2, this means that you want the scene asset to be completely re-downloaded. You can choose to only download the scene file itself or the texture or both. You can choose either. And once you've done that, you will see that the IndexedDB engine support JPEG, PNG, DDS, and TGA textures. And by default, it will always try to load this file. So a lot of people are worried when they're seeing a 404 in the debug console. This is normal because by default, we try to search for this manifest file. If you don't have one, this means that you want all the assets to be downloaded from the web every time, which is one of the options you can have. If there is one and the proper property set, we'll try to download everything on the IndexedDB and to load it only once to save some bandwidth and to increase the speed of the loading scene. So let me show you how it works. And we finally have the complete scenario to enable a complete offline experience. So it's not universal apps, it's offline. I'm going to close some of the projects to have a clean desktop. And I've got this project ready to be used, so let's have a look. Control F5. So this is a part of our website that I've been using. If I'm pressing F12 and put that here, you can have the network view. You've got to tick this specific option, always refresh from the server, to be sure that IE won't try to load from his own cache. So I want to force to reload from the web server. And I'm going to start the capture. So I'm going to load this scene. And you can see, as David was showing us during the beginning of the show, that it tried to load the Babylon file, then it's going to load a lot of JPEG and PNG files. So the idea is to have that loaded once, and then load it from the DB rather than requesting from the web server. Okay? So this is the same thing, of course, for the other scene. Beautiful scenes. And just imagine now that you've got a landing page with 2 levels, and this is the first level of your game, the second level of your games. If you're using HTML5 offline APIs, classical offline APIs, the only way you can use is to build a manifest and put every resources in it, and there's no delta updating in HTML5. You are forced to re-download everything if you're charging only one texture, for instance. In our case, we can update only one specific scene if you want to, by just modifying the manifest, which was the purpose of doing that. So now let's create the manifest. So let's go back in Visual Studio. So for instance, go to the scene part and rename that to art.babylon.manifest. Yes. Let's open it if you want to.
Seems like Visual Studio does not want to.
It doesn't want to open the file.
You cannot open it with... Oh,
here it is. So this is a very simple file. So I'm going to ask to download the scene offline and the texture. So let's do the same for the other scene. Let's rename it to .manifest. And this is the same story. Once I've done that, now let's relaunch the website. And let's compare what's going on now. So F12, let's clean everything. OK, stop the capture, relaunch it. Now I'm loading the first scene. And you see that IE asks me, do you want to let this specific website to have access to your offline data? I mean, to your resources, to your hard drive. If you say no, everything is going to work as usual, directly from the web server. If you say yes, it means that you let IE storing all the data in the local DB, and the next time you won't use a web server. So let's say yes. So you've got the very same output on the right. Let's go back. And now let's reload the same scene. And there is only one HTTP request going out. Just to load the manifest, he has loaded the manifest. You've seen that nothing has changed in the manifest. This is the same version of the file. So he said, OK, you want me to load everything from the DB. So you're not stressing anymore the web server. And this means also that we could easily enable some offline scenarios. So same story for the other scene. So let's go back to this beautiful spaceship one. OK, going back, reload it. Only one HTTP request. And now everything should be ready for offline usage. So the last part to enable offline use is to use HTML5 offline APIs and a manifest. So let's go back to the slide for that. Now to enable offline, you need to create a real HTML file manifest files, so which has a specific way to be written, like we can see here. So you need to start by cache manifest, specifying the version. You need to specify the file you'd like to cache through the broader system. So this is our engine itself, the HTML5, CSS, and various maybe image you're using. And once you've done that, IE is going to download all those files and going to run our engine. Our engine is based on IndexedDB, so if you try to load some assets from the DB, they will be there. So thanks to that, no more need from the web server. So we're going to check that, how to enable the full offline support. Let's go back to Visual Studio, close that one. I need to create a .babylon cache file. So you see that I'm not specifying anything linked to the assets themselves of the scene. So it's only the HTML5, the CSS, the JavaScript, some screenshot being used on the starting screen, and some asset being used to, for the logo and all that. And finally, the two manifest files, because we need them to simulate the XArray request. So they are important to be part in the HTML5 part itself. Once you've done that, you need to ask to to the browser to use this file as a manifest file. So it's manifest equal babylon.cache. And as David was saying, you need to modify the web.config also. So I've got two entries here. So the first one is for Babylon, is application/Babylon, and the second one is cache. So the proper MIME type should be text/cache-manifest. So otherwise, some of the browser won't understand it is a cache manifest for HTML5. By doing that, now I can press Ctrl F5. I can navigate to the theme. It's working fine. Now what I need to do, I'm going to close Visual Studio to check that I don't have anymore the web server running. And even if I'm closing the browser, I can relaunch it. This is still working, even if the web server is not available anymore, because I'm following the offline part, and I still can load all my scene and play to my game because we are using our IndexedDB cache mechanism built in the BabylonJS engine. So this is pretty cool. So now you can imagine building some complete game on the web working offline mode like a native apps almost. So I'm pretty pleased to see this level of support in HTML5. So if you want to go further, we've produced a list of links and articles on the wiki of our BabylonJS GitHub or on our blogs. So feel free to click on the links. And I've shown you also on my blog how to create some games for the Windows Store and how to build some universal application for the Windows Store. So feel free to have a look to that. And I guess this is concluding this second module of this second day.
Absolutely.
So we're going to take a 10-minute break again, and we will go back in the 7th chapter. We will see some beautiful things around physics, for instance.
Yeah, physics, animation. We will talk about really advanced features.
See you.
Bye-bye.